Hello viewers, now we'll discuss the rationalization of surds. Sometimes surds of the type 1 by root a or 1 by nth root of a or 1 by a plus b root x or a minus b root x or 1 by root x plus root y or root x minus root y or a plus root b or a minus root b. If denominator contains this type of surds, sometimes you need the rationalization of the denominator. Here the rationalization means conversion of surds to a rational part. That is, it will be free from any radical sign. Before we start the rationalization of surds, first I am discussing some important identities here. In the previous videos, we have discussed the root a into root a is equal to root a square, and root a means a raised to the power half and the square. So 2 and these 2 cancel, numerator and denominator. So finally we get a which contains no radical. So this is actually rationalization. Here root a into root b, they are not similar, and we know root a into root b is equal to root of ab. Root square root of a plus square root of b, and when it's multiplied this with square root of a minus square root of b, actually root a minus root b is called conjugate of root a plus root b, conjugate. So when you multiply it with conjugate, see what happens. It happens that as it is in the form a plus b, a minus b form, that is a square minus b square, that is an identity, and here we are getting root a square minus root b whole square, and already we have discussed the root a whole square is equals to a. So we write a minus root b whole square. So this becomes b, and see here again no radical sign, that is it is a rational number. Next one is a plus root b, and the conjugate of a plus root b is a minus root b. So when you multiply this, it becomes again a plus b to a minus b form. So it is a square minus root b whole square. Now this root b whole square becomes b. So we got a square minus b. The last one, root a plus root b whole square. This is an identity. Sometimes we need the square of these surds, root a plus root b whole square. As we know, a plus b whole square is equals to a square plus 2ab plus b square. Now instead of a and b, here it is root a and root b. So we are writing root a whole square plus 2 into root a into root b plus root b whole square. Now root a whole square becomes a, then plus 2 into root ab, so it is just root ab, and then root b square is b. So now we are able to do the rationalization. First number is 1 by root a. 1 by root a. We want to do the rationalization of denominator. So rationalization of denominator and denominator contains only root a. So as we know that root a, when it's multiplied with root a, it becomes a. So to rationalize the denominator, we multiply this with root a only. So then 1 into root a. So root a by a. 1 by root 5. Root 5 into root 5. So root 5 by 5. 3 by root 9. Root 9. Root 9 into root 9 by 9. So 1/3 of root 9. But if it is cube root of 5, how to rationalize? Cube root of 5, as it is a cube root, so we need 3 a's to get a. We have only 1 5, so we write cube root. We have 5. Now 5 and another 5. 2 5s are needed to make it a cube root. So numerator also multiplied by 5 into 5. So this becomes cube root of 25 by 5. So this way we are rationalizing the denominator. Next type is, if it is in the form 1 by a plus b into root x. Naturally, its conjugate. We find the conjugate of a plus b root x, and that is equals to a minus b root x. So we multiply both numerator and denominator by. We have this a plus b root x, and we multiply with a minus b root x. So right here also, now a minus b root x a square minus b root x whole square b square into x. Let's see an example. 3 plus 2 root 5. 3 plus 2 root 5, and its conjugate is 3 minus 2 root 5. 3 minus 2 root 5. 3 minus 2 root 5. Now it is 3 square minus 2 root 5 whole square. 3 minus 2 root 5. 3 square is 9 minus 2 root 5 whole square is 2 root 5 into 2 root 5. So 2 twos are 4, and root 5 into root 5 is 5. So it becomes 20. So now it is minus 11. Or we can write in this way, minus of 3 minus 2 root 5 by 11. Or we can write another way also, 2 root 5 minus 3 by 11. Now if it is in the form this, let's see, quick, tell me what will do here. We multiply it with square bracket. What is the conjugate of this one? Yes, root x plus root y. So root x plus root y. Now root x whole square, root y whole square, and root x plus root y. So root x whole square is x minus y, root x plus root y. Let us see an example. 4 by root 3 minus, root 7 minus root 3. 4. So now the conjugate is root 7 plus root 3. So root 7 minus root 3, root 7 plus root 3, root 7 plus root 3. Now 4 root 7 plus root 3 by root 7 whole square, root 3 whole square. So now 4 root 7 plus root 3, and here it is 7 minus 3, and 7 minus 3 is equals to 4. So now we can cancel these two 4s. So finally we'll get root 7 plus root 3. Okay, thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.